Okay, so in this question, we will see how we can solve this differential equation. Again, for your reference, I have written all the steps on the right hand side, but let us not look at the steps right now. Instead, let us start solving the question and see how steps work here. So the solution goes like this. The first step is always compare with the standard form. Now, if I compare with the standard form, which is m dx plus n dy is equal to 0, this value is m and this value is n. So m is going to be y plus xy square, and the value of n will be x plus x square y plus x cube y square. Now next we will find out dou m by dou y, that is a partial derivative of m with respect to y. I should get 1 plus 2xy over here. Please note x is a constant because it's a partial derivative. Now dou n by dou x is going to be, the derivative of x is 1. The derivative of x square y is 2xy, only differentiate x. And then this is 3x square y square. And we clearly see that dou n by dou y and dou n by dou x are not equal. So we should write down our conclusion. We should say since dou m by dou y is not equal to dou n by dou x. Now this is the test that is mentioned over here. We need to have dou m by dou y should be equal to dou n by dou x, but then it is not equal, right? And if this is not equal, then it is written. Then check if the given differential equation can be reduced to exact form by any of the 4 rules. We have total 4 rules. We have seen the first and second already, and then we will see how the third rule works in this particular question. So it is not equal. Let us write down this comment full. Therefore, the given differential equation is not exact. Okay, now we're going to use rules and we will try to reduce this equation to exact equation. Now, if you see this question over here, you can understand that from the m, the term that is with x, we can easily take y out common. So if I take y common out, this will become 1 plus xy, and this is y dx, right? I took y out. Now from the second or the n value here, we can take x common out. So this will become plus, this will be 1 plus xy plus x squared y squared, and x is out, x dy is equal to 0. Now if you compare this, this is perfectly in the form f1 xy y dx plus f2 xy x dy is equal to 0. Okay, so we need to have every term in terms of xy. Do you see this term is in terms of xy? Okay, now this 1 is a constant, so constant is no problem, or you can assume 1 as xy, the whole thing raised to 0. That is nothing but 1, isn't it? So constant is allowed, but then other terms must be in terms of xy, which is the case for the first one. So your f1 is definitely in terms of xy, and if you see this f2 or this bracket over here, this is also purely in terms of xy. This is 1, this is xy, and this is xy the whole square. Okay, and then you have x dy over here along with it. So it is perfectly matching the form. And when it is in exact form that we are looking for, it is said in the rule 3, if the differential equation is in the form f1 xy y dx and f2 xy x dy, if this is the form, then we can directly write down integrating factor, right? Integrating factor is that magic factor which will convert a not exact equation into an exact equation. So let us write down integrating factor. Integrating factor will be 1 upon, look, we have value of m over here, so to multiply m with x. Okay, so let us write that this is y plus xy square multiplied by x minus, then this is the value of n, and then multiply that with y, right? So it is x plus x squared y plus x cube y square multiplied by y. So we get integrating factor if is equal to 1 divided by, let's multiply this x inside. This is xy plus x square y square minus multiply by y here as well, minus xy. This will be minus x square y square. Do you see there's a minus sign outside? And then this is minus x cube y cube. So we've got all these terms, and if you see carefully, this x square y square and minus x square y square cancel out, xy will cancel out, and I'll get integrating factor as only this. So this is minus 1 upon x cube y cube, and that is the integrating factor. Okay, as soon as you find integrating factor by any of the 4 rules that we have, we will simply use that integrating factor and we will multiply our m and n with if. See, m dash is what we call it, is m into if. Okay, the value of m is over here, which is y plus xy square, and the value of if is negative 1 upon x cube y cube, right? So when we multiply this, let us simplify this a little bit. This will be 1 upon negative 1 upon, when I divide y by minus x cube y cube, it will be x cube y square. And the second one, when I multiply here, this will be minus 1 upon x square y. And this is the value of m dash. Now, once we find m dash, next thing you will find is n dash. And n dash is going to be n into if. Okay, so the value of n is over here, and we'll multiply that with if. So this is x plus x square y plus x cube y square into minus 1 upon x cube y cube. We can actually take the minus sign outside, this one here. Okay, and then let us divide this whole thing by x cube y cube. So this will become 1 upon x square y cube. Then this will become 1 upon x y square. And the next value will be plus 1 upon y. Okay, and this is the answer for n dash. So we have found out value of m dash. We have got the value of n dash as well. And it is written over here as well that m dash dx plus n dash dy is 100% exact. You don't have to check again. You can directly say that it is the exact equation. So we'll write down, we know that m dash dx plus n dash dy equal to 0 is an exact differential equation. Okay, and because it is an exact differential equation, therefore solution of exact differential equation is written like this: integration of m dash dx plus integration of n dash dy is equal to c. Okay, with the condition that the first integral you will have y as a constant for the first integral, and for the second integral you will take the n that is free of x. There should be no x term in that n dash value here. Okay, so let us integrate this. We have m dash and n dash ready. So let me clear some space and solve the integrals. So now the integral is, this is, we can again take minus common over here. And then m dash values are here. This is 1 upon x cube y square plus, I took the minus out. This will be 1 upon x square y dx. Now please note here, you will have to treat y as constant and then plus, okay, again there is a minus sign here, so this will become negative integration. Now while you're taking n dash, you have to ensure that you don't take any term of x. So you can't take this term, you can't take this term as well, so you'll only take this one. Okay, you'll only take 1 over y as a term here. So this will be 1 by y dy is equal to c. Now we have to solve this integration and we will get the solution to the differential equation we have here. And first integral will integrate, and remember that y is constant. So we will take y square out. So the first integral is going to be the minus sign. Okay, I can just like, okay, let's keep the minus sign as it is over here. I've taken the minus sign common from both of them, and y is constant. So 1 upon x cube. Let me write the integral like this: 1 upon y square. I took that as a constant out. Integration of x raised to minus 3 dx. This is the first integral. Now let us write down the second integral here, plus 1 upon y, which is a constant, and it is integration of x raised to minus 2 dx, the second integral. And then the last one is minus integration of 1 upon y dy, that is with respect to y. And then I'll write down this as c. Okay, then I can always take this minus on the other side. This minus over here, I can take it on the other side, and let us integrate here. This will be 1 upon y square. Then the integration of x raised to minus 3 will be x raised to minus 2 upon minus 2 plus 1 by y. This is x raised to minus 1 upon minus 1. And this is minus 1 upon y. The integration of 1 upon y is going to be log y is equal to c. Okay, this is the answer that we have got. What happened to this minus sign? The minus sign can actually make this there is a minus sign outside, right? So, okay, let me write that minus sign as it is. And then that minus sign can just come in and then cancel this whole thing out. Yeah. So the bracket is like this though. And it is common from the left hand side. Fair enough. So just do these adjustments. Okay, minus sign comes in and you will get the first one as 1 upon 2x square y square, the first term. Then the next term will be 1 upon xy minus log y is equal to c. You need not simplify more. This is the final answer of differential equation. Now in this question, we have used rule 3, and the original equation that is given to us was not an exact equation, but we've used rule 3 and converted the non-exact equation into exact equation.